and obviously get in touch always if you have any questions. So without much further ado, let's start Vision 40 and show you some of the new things that we've been working on. So minimize this a little bit. No, that's not what I wanted to do. That's what I wanted to do. There we go. So we try not to make anything too radical because obviously we have so many of you users who've been using the software for a while now, and we don't want to be confusing everyone. So at first glance, everything will be very, very similar. But it's really when you start going into the new pipeline operations that you'll see some significant changes. Let me just close my door and not annoy my wife, who's also working from home at the moment. I'm sure you guys have elected to listen to me talk all afternoon. My wife doesn't necessarily. She likes a peace and quiet while she's working from home. So I'll try and give her a little bit of that. Anyway, so okay, so let's get started with some of the new stuff we have in Vision 3.2 and specifically in the pipeline. So as always, you access the new pipelines analysis panel either through the Conical Flask icon up there or through the analysis menu, and you've got the analysis panel in there. So for all of you who are familiar with the software, who've been using it for a while to do things like image analysis, you will notice some things immediately. It looks just a little bit different. And there's a few things that we've tried to do to make this as easy to use as possible. So one of the very first things that we've implemented is a new design that is a little bit cleaner and easier to access, and with the ability to collapse and expand specific operations. So you already know that if you build a complex pipeline, you very quickly get to a point where you're having to scroll through the pipeline to see all the operations. And so one of the things we've added is the ability to collapse operations. So if you finished setting the parameters for the input RI, for example, you can just collapse this operation and then it takes less space in your analysis panel. And we also have added the ability to collapse all of the operations. So right up there in the analysis panel toolbar, you can see we can collapse all of the operation or expand all of the operations. It just makes it really easy to just quickly get to just the operation that you're looking for. Another thing that will look also immediately obvious when you have this view here is that we've added a few more icons in the operations title bar, and specifically we have this preview icon. So instead of searching through the panel for this specific preview, you can just click on the preview and you get your preview directly on the screen straight away. Linked to this, and specifically with regards to the denoising filter that I've got in this pipeline right now, we used to make a distinction between 2D and 3D operations. So if you've got Vision 40 3.1 or earlier, you see that we have denoising filter and you have denoising filter in brackets 3D. And so what we've done to make it a little bit easier is we've bundled all of the denoising operations into one thing. So you no longer have to worry about whether it's 2D or 3D. Linked to this, of course, is also the fact that by default, most of these operations run in 3D. And by running in 3D, I want to make the distinction that when we say we run operations in 3D, what we mean is that we process multiple planes at the same time. So in Vision 40 3.1 or earlier, if you used a 2D denoising filter, it would process the entire stack as long as that's what you selected in the input RI, but it would do it plane by plane. Whereas with all these filters, the operation runs through blocks of 3D voxels. The slight downside of this is that it can be a little bit slower, certainly to get a result on the screen when you're running the operation, but it brings us some tremendous advantages in terms of the quality of the result that you can get in most cases. So linked to this is the fact that the preview, as it was with earlier versions, is always only available in a 2D view, and it's always calculated in a 2D view because, again, we don't want our users sitting twiddling their thumbs waiting for things to happen. So the preview that you see when you click the preview icon is very quick, as you can see, but it's calculated on a 2D plane. And so what you may find is that the actual results will look just very slightly different if you look at the result in 3D. So I'm just going to mute my colleagues because there was a bit of background noise there for a second. And let's minimize this back again. Right, linked with the new preview icon, which is, as I said, directly in the title of the operation, you'll see in most cases you have the preview slider immediately below it. So while before we had a little drop down and it was fiddly and it's a little bit awkward to use, here you can use a slider to change the opacity of the preview, so you can really easily see the difference between the processed and the original data. Again, it's just about making it really easy for everybody to see that what they're doing is providing the right results. So we've made all these changes, and as I said, with the denoising filter, by default, these operations run in 3D. But if you still want to run these operations in 2D because it's faster, or because you've only got like a non-ideal Z separation, in the operation menu, there are additional options. So, for example, here there is this perform plane-wise operation. So that means the software will do the operation plane by plane for the entire stack, just the same as the 2D filters did in earlier versions. And again, also, if you want to be able to compare results, maybe you had pipelines created in the earlier version and you want to make sure that the results are comparable, then that's always available here. You'll find a few other operations here, like, so if you're running a pipeline, you can choose to say run the pipeline up to this point, and that makes it a little bit easier. We've added a few new operations in the pipeline as well. So you'll find we have a new distance map operation, for example. This is something that a lot of people have been asking us for a long time. It is something that I've been fighting for you on your behalf with our engineers to make sure that this has been implemented for a very long time as well. I'm delighted to have this in, and we'll probably cover this distance map operation in a future meeting, or maybe if we have some time today, I can show you some of the new results. But we've also added a new normalization operation. So normalization is there to help you manage uneven elimination to some extent. As an image analyst, my ideal scenarios would be for every image to be pixels be white if they're part of an object and black if they're background, to have no noise and everything else like that, to have no bleaching, no signal attenuation as you go through the image. But unfortunately, it's a fact of life that in light microscopy, in imaging in general, you can't always guarantee perfectly reliable degrees of intensity throughout the image stack. And so the normalization can help with this. So with an image set like this one that we've got here, you can see as I go through the time series that the signal attenuates and gets a little bit weaker. You can use bleach correction. This is still available. You can find it under the data menu. We have bleach correction right here. But that creates a new image set where the intensities are changed. What we can do with the normalization in the pipeline is you can essentially do the bleach correction only for the purpose of the detection of the objects, but you carry on measuring the intensities on the raw data the same as we've always done in Vision 4D. So when you're measuring the intensities, you're measuring what was measured by your sensor, not some modified version of your image with all of the kind of things that implies. So I've already shown you the denoising filter operation last time when we showed you the tracking. So I'm going to kind of run this again, and then you can see the difference that the new normalization makes. So I'm just going to finish this operation. We'll see this data set is, as you can see, quite small, and so it should go pretty quickly. Another nice thing, we've made it a lot easier to see right at the top of the pipeline the current rate of progress to make it a little bit easier to see. It was one of those things that drove me crazy with the other version, that we had it in white font on a grayed out title bar, and it made it really difficult to see with the rate of progress. So I'm really thrilled about this as well. You can see little things really please me. I do believe there's a saying that little things please little minds. But you know, in these isolation times, it's great to have these features. The other really good thing about the batch analysis, about the normalization, is that it makes it really easy to set thresholds for batch analysis. So if you have multiple well plate images, for example, where some wells don't have the same kind of overall intensity, you can't use an intensity threshold so easily. But with a normalization, that makes that particular step a lot more reliable and a lot more useful. So the normalization can be done on a single channel or multiple channel, just the same as any other operation. And there are a variety of means for carrying out the normalization, so-called global and local normalization methods. And global normalization methods are really there to kind of stretch out the histogram to the full range of the image in a systematic fashion. So what we do is we take the signal and we essentially put all of it at going from 0 to the maximum value over the histogram. But how we set the threshold is based either on a histogram, on a mean variance of the histogram, on a single sigmoid function, or on a so-called simple normalization. And it just makes things I guess the best way to do it is to show you. So if I run this histogram-based normalization, you see we can set a percentile. So you can say, well, maybe I want to take like the bottom 1% of intensities to the top 99% of intensities, and we're going to set that for each time point. So we take whatever the bottom 1% of intensity in each time point, the top 99% of intensities in each time point, and we're going to set those at 0 or to 65,535 if you're in 16 bits, or 255 if you're working in 8 bits. So if we run this operation, you can see first is that it looks super saturated, but if we wait a second for the operation to finish, what you'll see is actually if we do an auto scale now, you see the scale now goes from 0 to 65,000, whereas before we had intensity of up to only about 600 grayscales. And the other thing you see now is that as we go through the time series, the bleaching becomes a lot less significant. And this is also especially true as we see it in 3D. So if we give it a second, we can see the image here, and you can see the level of signal is pretty much the same throughout the entire time series. Whereas if I compare that to the original data, so if I go back to the original data here and go through the time series, you can see as we go along, all of these green objects tend to shrink quite a bit, the red objects almost disappear, and that's due to the bleaching of the signal. So this normalization, as I said, it's great for being able to set constant thresholds. It's absolutely perfect if you're doing batch analysis, and you know, try it out. There's a lot more to it than what we're able to convey in a 45 minutes webinar. But we can't wait to put this into your hands again, like everything else. Okay, so if I go back to my results, as always, we have the option to choose how we store the results. So just a quick reminder for anybody who missed the first meeting, it's always very important to make sure that you have lots of space on your hard disk to store the results of voxel operations, any kind of operations that process the image. We generally recommend that you have about 5 times as much free space on your hard disk as the data you're trying to process. That's the kind of rule of thumb. And you know, if you want to review this, by all means do and check out the recording for our first webinar where we went into quite a lot of detail on this. Okay, so we've got a few more operations in there. We'll see if we have some time to do the distance map later. It's a great operation for some specific tasks. We've also enhanced a lot of segment generation operations. So, for example, here we have our blob finder. It looks very similar, but we've kind of made it a little bit easier to use with this normalize option. And again with the preview, so if you're in a 2D view, you can preview, and if you have the preview going, you can, as with the other ones, you've got really quick access to the sliders to adjust the transparency. So we can adjust the split sensitivity to make it less likely to split objects. So we can do something like this. You can change the diameter. Again, the diameter, we've made it really easy to set this by putting in the ability to put the ruler right here in the preview so you can see quickly what that looks like. And as always, I recommend changing the name of the operations so that we use a more sensible tag than blob finder, because we might use the blob finder segmenter for more than one operation. And when you're reviewing your results, knowing which one is blob finder 1 and which one is blob finder 2 isn't necessarily so intuitive. So we can call that channel 1 segmentation, which makes a bit more sense in this case. Okay, another new operation we've added in the segment generation operation is this seeded region growing, and I'm going to show you this in a minute with another data set. But the idea is that if you are dealing with a membrane-based segmentation, if you've tried our membrane-based segmenter, you know that the results are very highly dependent on the quality of the staining, that the membrane-based the membrane enhancement filter can help with this, but it's very time consuming. And the region growing segmenter can help with this by allowing you to first work on the assumption that any nucleus is going to be the center of the cell. And so what you do is you grow from the boundary of the nucleus out until you find something that looks like it's a membrane. And it can be a lot faster and a lot more efficient. And if you have uneven elimination or uneven dye distribution, it's absolutely brilliant. I'm going to show you that later. We also have a new machine learning segmenter, and again, we're going to show you that later. We're going to have a whole section on the machine learning, which now supports the ability to segment across multiple channels simultaneously. So it's a little bit more efficient in that way. And there's also the watershed-based segmenter, and the watershed-based segmenter is great for kind of objects that have a specific kind of edge, essentially. And so it kind of works a bit like the region growing, where you kind of find seed points and then you grow out. So all of these things we can cover. So if we have a look at the preview here for channel 2, you can see we can set an intensity for what is a seed point. And again, you can pick on the image directly. With the preview here is automatically updated to show you the foreground, so you can see the intensities as we're picking them, but you can switch the preview back to see the results. You can set a diameter of how fast it's going to go, and also the split sensitivity again. So if you have objects in close proximity, it's really good at trying to separate these ones out. So maybe in this case, I think actually the blob finder is probably slightly better detecting the objects in our second channel. So again, you can preview this. I'm going to have split sensitivity that's much lower. Okay. And because I want to have two segmented object types to show you some of the new things to do with the distance operation and compartments operation, but the distance operation first. So with the distance operation, if any of you have used it before, you'll know that it works by essentially measuring the distance between so-called reference objects and subjects. And so you can use it as purely as a distance measurement operation. You can also use it as a filter to identify only objects within a certain distance range. But the other thing you may remember is the fact that the distance operation works based on the distance between either the edge of the object, so the surface of the geometry of the object, or the edge of the bounding box, or the center of the geometry, the single center point of the geometry or of the bounding box. And depending on which one you use, you obviously get different degrees of accuracy and different degrees of speed. But in 3.1, this distance measurement was always linked. So the reference and subject, if you set distance from edge to edge, it was distance of the surface to the objects. But if you have complex surfaces, then that's maybe not so ideal, because you can have very complex surfaces and it can take a really long time. So if you add the distance operation now to your pipeline, we've cleaned up the interface a little bit, so you can choose where you measure from and to. So I forgot to rename my my second segmenter. So my bad. So we've cleaned up the operation. So what you can do now is you have this option to filter or not. So you can say, I want to filter objects whose distance is less than a certain distance from the references, or greater than, or within a range. But if you're not interested in filtering the distance and you just want to know the distance to the nearest object, you can just do it like this. But if you expand this dialog, again, we've kind of made it a little bit easier to see when dialogues can be expanded. So let me collapse everything and just expand just this one, so you can see a little bit more of the operation in here. You see we have this section here for the distance calculation where you can choose where to measure to and from. So like typically when you're measuring distances between two object types, in the majority of cases that I've seen so far, what you tend to have is one object type tends to be significantly larger than the other one. So maybe you're measuring the distance of some cells to a cluster, some cells to blood vessels. The blood vessels, the cluster is a huge object. The cells are very small. And so what you can do is that by default, we set it so that the distance for the subject starts from the bounding box, because usually that doesn't make much of a difference. And the distance to the reference is based on the geometry, so the edge of the surface. But you can set these individually, so you don't have to have them linked to each other anymore. So if you measure the distance from center to center, you'll get the fastest results. If you get center to surface or geometry, you can get some more accurate results as long as the subjects are relatively small. But if you need to measure edge to edge, you can still do this. So it's just a lot faster, and you'll be able to see this in a second. I've added a few other options here. So group by reference, we already had in 3.1. And this is all linking together with this new compartment operation and the whole concept of parent-child analysis. I've just finished recording a video tutorial on this, which will be going live at the same time as we release the software. So I'm not going to go into too much detail on this, but this grouping makes it really easy to establish parent-child relationships. So maybe you want to count number of specific vesicles inside a cell, and you do this by grouping them to a nucleus, and the distance filter can help that and make it really easy. So when we run this operation, you can see with the center to center, it's really fast. Automatically, we get the distance results inside the pipeline in the objects table, so you can quickly see which objects is which. So if I double click on an object here, you can also see this object, its closest neighbor is 2035. So if we have a look, make this table a little bit bigger, we can go to the object, and you can see, we should be able to see that object. And oh yeah, because it's a reference, it's going to be one of those. So it's that one. And this one's very kind of funky, but anyway. So so it's really easy to then go and measure distances, also filter based on distance, and as I said, to group objects based on distance as well. Another feature that we've got here, I'm going to go into the region growing now very quickly. So I'll have a look at some of our demonstration images. Okay, so this is a typical example where you might want to use region growing. If I hide the object for a minute, you can see here. So we have those nuclei, and you see the membrane, but as you can see, the membrane definition is quite poor. And so if you try to use a membrane-based segmenter, it's probably going to really struggle with something like this. If we were to try and use the membrane enhancement filter, it would be very time consuming. But the new region growing is really quite adept at detecting these things. So if you have a look, here's our pipeline. So we can do a particle enhancement filter to better find the nuclei. Let me just minimize this. Yep. And again, preview on the web channel. Let's have a look. Okay, and so now we have this new seeded region growing you should find in the segment generation operation. You can also do it as a two-step operation where you first segment the nuclei, but with this, what you get is you get to see straight away in one step. So if you want to see the seeding results, you can see here is our seeds. Again, you can change the threshold to make it a little bit easier to detect what you're looking for. And for every object that is identified as a seed, the software will try and detect an object around it by growing from that seed. So we have two parameters. We have parameters for the seeding. So nuclear base means that you're looking for essentially blob-shaped objects. And then membrane base obviously is based on membranes. And then you have a second parameter here, which is for the actual region growing. So the region growing can be based on a watershed or on a membrane-based watershed. So the membrane-based watershed assumes that you start with a dark object and you've got a bright boundary between these objects. Whereas with a watershed, you kind of, maybe you have a cytoplasmic stain, and what we look for is a die-off of that cytoplasmic cell, a stain as we reach the edge of the cell. So in this case, we'll use a membrane-based watershed. And the last parameter you can set here is the maximum distance. So with a region growing, essentially you kind of grow until you get either to the edge of an object. But if the membrane stain is really weak in some places, then you don't want it to grow indefinitely. So it might just leak through that gap there and grow indefinitely, and obviously that wouldn't be ideal. So there is also in here a max distance parameter. So you can say, well, I know it should really never grow more than a certain distance. So it avoids the region growing running away with itself. So as you can see, this operation is pretty fast. If you've ever tried the membrane-based segmenter, you will be familiar with how slow that could be. But as you can see, it provides great results. And obviously, this is a 3D thing. So now you can see we've segmented all these cells. So this region growing is much more efficient. It takes a little bit of getting used to and learning, but it can be so much better at detecting these types of images, these objects in images where the signal is less than ideal. So linked to this is also the fact that in here we have, as a segment operation, we have a region growing operation. So essentially, as I said, you could use the blob finder to segment the nuclei and then grow using the region growing, because with the region seeded region growing, we do use a kind of more of a threshold based intensity segmentation to detect the seeds. And so with a region growing operation, you can potentially get better results. Okay, so I wanted to also show you with another image set that we have here. How seeded region growing might work better if you're using a watershed rather than a membrane-based edge detection. Why is it taking so long? Maybe close some of the other ones. Yes, I think I know what it is. I think I have this image opened under a different username. My apologies, bad planning. Okay, anyway, we as I said, we will have tutorial videos looking at all of these coming out with the release of version 3.2 in the next couple of weeks. I thoroughly recommend that you go and watch them, not just to make our poor applications engineer feel better because I spent hours producing these videos, but also because we think it's a very valuable resource. So I wanted to show you some of the new things with the new machine learning segmenter. So I'm going to close these to keep things a bit tidy. And this as well. Okay, so with the machine learning trainer, we've implemented a few things. So the first and potentially most important change is the fact that now the segmentation can be done on more than one channel at a time. So for any of you who are unfamiliar with machine learning, generally the principle is that we use a software algorithm to detect what is an object based on guidance from the human rather than based on specific thresholds. So as a user, you know what your objects look like. So you can get pretty much anyone to so most people know what their objects looks like pretty well, and you can get them to point at the image and say, so this is the object, this is an object, and this is an object, and this is background. And you don't need to know much about image analysis or the structure of intensity matrices to be able to do this, because we kind of this is kind of built into our brain from years of practice at detecting and recognizing objects. So on a very kind of abstract level, if you like, you can basically give a computer thousands of images and tell that computer all of these images contain cats and all of these images don't contain cats, and then the software can learn from the various kind of patterns in the images to recognize new images that also contain cats, or whether they do or do not contain cats. So in this case, we're doing essentially the same thing, which is we teach the software what we think is an object, and then the software makes a decision based on what's called a random forest pixel classification. So it's still essentially a pixel classification algorithm, and it's not going to recognize cats. Unfortunately, that's more related to deep learning and pattern recognition. But essentially here, what you could do is you can say, right, so if I select, like for example, class 1, I could say all of the pixels that look like this are representative of my class 1 of objects. So I make the point of making the distinction to say these are pixels that are representative of class 1, right? And then the same way you could say, well, these pixels here are pretty representative of my second class of objects. And then we can say, well, all of these pixels here, they're pretty similar all to each other, and they all represent background. And so what the software does in the background is it measures the intensities of these pixels in all of the channels that we have available or selected. And it also does this based on a range of filters. So you can base it on the intensities, on an edge detection filter, on the pixel textures, the orientation of any kind of gradients in the image. all of these things. And so you kind of blast and generate all of these potential images for all of these potential channels, and you look for how different those pixels we've selected are from what is background. So if we go back to this, for instance, EM Robust, which is our kind of default go-to with everything turned on, and then you can say, well, let's have a look at what the results look like. So at the bottom, we have a preview where you can see the probability that is a pixel. So essentially, we create an image in the background, which is classifying every pixel and saying how likely we think that object is to be inside of, that pixel is likely to be inside of an object. And then based on this probability map, the software will do a threshold. So when I click on probability, you can see at the bottom of the screen, it's now, it's just finishing calculating or training the algorithm to recognize those pixels. And now it's computing the preview. So it takes a little bit of while, because we're generating all of these images in the background, so it's very computationally intensive. But you can see already it's automatically detecting. So I didn't set a threshold. I just said those are pixels of type 1 and those are pixels of type 2. And so you see these have a low probability of being of type 1. And so they have a very low yellow overlay. And again, as with the preview in all the other pipeline operations, you can change your opacity to make it really easy to see what's going on. Now, along with previewing the probability or the uncertainty for individual object classes, you can also see a preview of the results. So it's going to take a little bit longer to calculate the preview. And again, it's going to update in a couple of seconds. But the advantage of this method is that while the computing is more resource intensive, because we are generating all these images in the background, the advantage is for the end user that they don't need to be trained on the kind of nitty-gritty of segmentation techniques. What does a threshold mean? What are the best filters to enhance an image, and so on and so forth, because the software just tries everything and then produces the results, as you can see here. So with this preview that we've got here, along with changing the opacity, you can actually fine-tune the results. So we have these sliders for smoothing and threshold. So at the moment, you can see the edge of the objects is a little bit rough. So if we increase the smoothing, you'll see that the preview is recalculated and the edges of the objects will be a lot smoother. So again, as I said, it's pretty computationally intensive, so it does require a little bit more patience, but it can, in many cases, provide much more accurate results, especially for complex data sets like EM data, where you don't have multiple channels typically. You don't typically have a nice differentiation in terms of intensity between background and objects. It's more to do with textures, etc. And so you can see this machine learning can be a lot more efficient at detecting certain object types. So when you finished creating a training like this, you can then open it in the pipeline. So if we're happy with the results we're seeing straight away, we don't have to wait. We can just say open in pipeline, and what this does is it creates a brand new pipeline with the parameters from the machine learning trainer already loaded. If you've created more training, so maybe you've created a training for detecting different object types, you can select them right here. And you can then build your pipeline just the same as any other. So again, these operations all the time consuming and processor intensive. Like everything else in Vision 4D has been built to be able to run on any image of any size. So you can rely on Vision 4D to do the analysis even with huge data sets. So that was my segment on some of the new features in the 3.2 version. As I said, we're dying to have it out there. I've been playing with this version now with various betas for the last couple of months, and it is just, even in my opinion, quite a lot better. There's many things we want to show you, maybe in our next webinar, with regards to the new Magic Wand tool, for example. Some of the really nice enhancements we've added to the 4D viewer, like the ability to create color legends for object coloring. So you may remember from previous webinars that you can color objects according to features, and now you can actually have a legend directly in the image to explain what the color means. But anyway, there's so much to cover, and hopefully you're all staying safe and healthy, and we'll see you all next week. But if you have any questions, now's the perfect time. So I have one question here already, but if you have any other questions, then by all means put them in the questions tab, and we'll try and answer them over the next couple of minutes. So two questions. Can I import pixel class elastic formats in the machine learning pipeline? Yes, you can. So this is new in 3.2. We've improved that, and yes, you can improve elastic segment trainings in Vision 4D. And can I apply the training on different image sets not previously trained? Absolutely. So you can import and export those trainings, and provided that the image data is similar, you should be able to use it with any image set. So any other questions from anyone?
We have another question, David. We also have a question about the region growing. If it's possible to, for example, or if you always need a second channel to apply the region growing algorithm, or if it can be applied using the same channel.
No, it can be done in the same channel if necessary. If you have an image where maybe you have a staining that is expressed really strongly in your nucleus and is then very diffuse in the rest of the cytoplasm, then maybe you can use the blob finder first to detect the nuclei, and then you can use a region growing to grow to the edge of the cell by using the diffuse staining in the cytoplasm. So yeah, you can do this region growing on one channel if necessary. In most cases, it makes more sense to have two separate channels, but certainly you can use one channel for both.
Thank you, David. Another question is, first, if we can use machine learning with batch processing, which I think
Absolutely.
this is also in line with our previous question, if we can apply machine learning in multiple images.
Anything you can run in a pipeline, you can run in a batch. This is true of pretty much every operation that you can put in a pipeline. So the training will be part of this, and so yes, you can run batch analysis with machine learning segmentation. I've got another question here that's come up. How efficient is a machine learning tool with histology images? It really depends. So whether you're talking about bright field or fluorescence, try it out. It depends on a lot of factors. It's not, there's no real reason to think it'll be any worse than with any other type of data. Yeah, I mean, colored images, I'm assuming by colored images you mean RGB images. so probably bright field images. And in that case, yeah, it'll work. And in fact, the new version, which obviously, as I said, works with multiple channels. With Vision 4D, when you import RGB images, we actually split the RGB data into 3 separate channels. And so this new version is much better able to deal with that than the machine learning we had in 3.1. So yeah, it should deal well with it, but try it out. See what works, see what doesn't work. You know, and if you have any questions, you know, we're always keen and eager to help out. So if you want to send some specific images related to your question, we can have a look at them for you. But otherwise, you know, this will be, you'll be able to use this version in a couple of weeks at most, and yeah, try it out.
We have another, well, this is a comment that in his experience, it can work very well on any type of histology data, this kind of machine learning segmentation. So thank you very much for the comment.
If I don't have much space in my hard disk, is it possible to save 10 file on OneDrive? I really wouldn't recommend it. Yeah, so one of the reasons why it's important to have space on your hard disk is because Vision 4D makes very extensive use of just-in-time loading. That means we load into memory only those pixels that you need as and when you need them. And so what I'd recommend is that you offload to OneDrive any of the data that doesn't need to be on your hard disk right now, and then make space for your temporary documents and everything else on your hard disk. You can, if you have problems with storage, first is if you're using a desktop computer, it's usually pretty easy to add additional hard drives. Most computers have spare SATA ports that you can plug your hard drive into, or if you have a spare PCI slots, you can use a PCI-based SSD, and you can get 2 terabyte SSDs for about €200. So if that's a problem, you can do that. If you're on a laptop, obviously internal storage is a little bit more limited. Obviously you can replace your hard drive with one with a larger capacity, but the other thing is most modern laptops also have so-called Thunderbolt ports or USB 3 type C ports, and these are much faster. So you could set your temporary documents onto a removable drive. I wouldn't recommend this because if the connection fails because your hard drive gets disconnected or whatever reason, or your computer decides to turn off the USB port to save power, then the analysis will probably fail because it loses access to the data. But you could set this to a removable hard drive. But if you're running out of space on your hard disk, then I would say the first most useful thing you can do is back up any of your the data that doesn't need to be on your hard drive right now because you're not accessing it on a regular basis onto an external drive or a removable hard drive or something like that. But yeah, have space on your hard disk. Make space for it. Any other questions? No, it looks like we've run out of questions from you, our attendees. Again, thank you all very much for joining us on these webinars. It's great to see so many of you every week. It's really encouraging to find that so many of you find this useful. We're going to have another webinar next week. We're going to look at some of the additional new features in 3.2. If you have any specific topics that you'd really like us to cover, get in touch and let us know. We can make room to add some more. And if you have any questions about any specific data sets or any specific analysis pipelines, get in touch with tech support. We are here for you. We have several members of staff whose job it is to help. So if you don't take advantage of this, then you know, it would be a very it'd be a crying shame. But thank you all very much for joining us today. We hope you have a very good what's left of the day, and we hope to see you all next week in our next webinar. Thank you again.